And the update observers will pass the new value up to the view. And it'll be like, let's say it started out as 0, and by the time it gets to here, it goes from 0 to 1, and it passes a 1 up to the view. And the view will implement something where the view will change its label to reflect the new value of whatever it's receiving. Any other questions before we proceed? I think that's pretty much the entirety of the controller written out. It has no other functions aside from translating users' actions from the view into something the model can realistically understand. Obviously that can get a bit complex with more complex programs, but then you need to get a bit more clever about how you structure things. No other questions? Good stuff. For the view, I will. There's a lot of writing on this, but. Yeah, now we get to the view part, which I suppose is kind of one of the more interesting parts of the program, in that in this particular case, the view is actually going to be substantially larger in code than the model ever was. But in most realistic cases, the model is the deep part and the big part of the iceberg, and the view is just this tiny little section of code that actually deals with drawing stuff on the screen. I'm going to try and keep this as language neutral as possible, but basically we want our public class fair enough. So we have a class called the calc view, or whatever your program's thing is going to be called, and it implements the count observer. Now, we're implementing an interface, so we're obeying a formal contract to implement a method. What was the name of the method? Update count or something. Right, first thing we need is, obviously, the view needs to hold a reference to the controller. We'll just call it C. And we're going to have like a window W button called B and a label called lab or something. For the constructor, we'll just we'll take in a reference to both the controller and the model. So what, obviously, in the last object we built as a controller, we saw how that built its own view for itself. It was given a model, but it built a view. And as the view is constructed, it'll take in a reference to that controller. So we can kind of see how the three separate objects kind of own references to each other in some ways. We're kind of keeping it to an absolute bare minimum because this view does need a reference to the controller in order to be able to communicate with the rest of the program. But we're not going to retain a reference to the model because that would be kind of redundant. If we're communicating through the controller object, then communicating directly with the model object becomes, like, as I said, kind of redundant. I'm really struggling to remember how I actually implemented this. Yeah, so if we say, whatever, our controller C equals controller from there, like it's assigned to our instance variable, and then model dot register observer. And we pass this object itself to the model in order to get that registration thing done. And from here on out, there will be, in that array in the model, there will be one reference to this specific view. And after that, they cease communicating entirely. And obviously we'll do a load of other initialization stuff to get the window and the button and all that kind of stuff on screen, but that's way beyond the scope of what we're doing today, and it's not particularly interesting either. So now we're pretty much set up for this stuff to work. One of the major things is when you're setting up the button, you'd add an action listener of some sort, so that you'll set it up. Again, it's beyond the scope of what we're doing here, but you set it up so that the controller listens for actions on the button, and you just do that kind of passing down sort of thing. And the last thing we need to really implement is we need to obey this contract that the view kind of swore to obey, because when the model sees that this thing implements this particular method, it'll obviously send it the messages expecting it, because it has a type count observer, and obviously anything of a given type must respond to the messages that type is expected to respond to. So we'll override the update method from the interface declaration. I think it's called update count. It is. Brilliant. And all we really need to do, take in an integer, or whatever. All we really need to do is something along the lines of label.setText to int. Any questions so far? Is that making any amount of sense? Anyone got any sort of reservations as to how that was done? So if we follow the execution path again, we'll just finish off that sort of thing. Yeah, so the view, a button is clicked, +1. The obvious intention is to add 1 to whatever thing the model is holding. Again, the view isn't aware of how that's being stored. For all it knows, it could be a float, or, I don't know, a sequence of binary digits strung together in an array and interpreted as being an integer or something. First of all, it doesn't need to know about it, because its only purpose is to display things to the user. The model's only purpose is to deal with that other stuff, and it has no interest in displaying things to the user. So that's kind of a very good reason to keep things separated. Basically, in object-oriented programming, you should always be striving to have your objects only fulfill one responsibility. In other words, that when you come back to edit this program, each and every class should have only one reason to change. If you find that a class has maybe 2 or 3 separate reasons why it might need to be edited, you're probably looking at an object that has far too many responsibilities for itself to keep track of. And obviously, the more responsibilities an object has, like for instance, if we didn't do this at all and we had to get all in one huge class, it would become very difficult to actually figure out what's going on, especially 6 months down the line when we come back to it and we're trying to make some sort of edit. Maybe we tried to add a minus button. You can kind of see here that if we wanted to add a minus button to the view, it would be fairly trivial to do it. We'd only have to implement maybe 3 methods, 1 in each of the layers. But if they're all in one place, we could end up in a situation where our logic for doing that calculation was all tangled up with itself, and would be fairly difficult to work. So yeah, buttons clicked. It calls the plus button clicked method in the controller, which then calls the +1 method in the model, which updates its observers. And because this guy just happens to be registered as an observer, if it wasn't, it would still do the update observers thing, but nothing would happen. It does its broadcast, but nobody's really listening to it, which would be fair enough. And that passes back up the new value to the view. I mean, maybe in some other situation you've got this thing where it needs to be updated on a change to, I don't know, a change to the score in a game or something. And like every time the score changes, yeah, you can imagine if you're playing some sort of video game, maybe it's Mario or something. And every time the code executes where Mario like jumps on an enemy's head or something, it'll change the score, and then whatever view is there might be registered as an observer of the score. And you might actually have separate windows or separate panels of a window dedicated to one field for displaying the score, one field for displaying the time remaining. Obviously, you've got 2 separate variables being kept in sync there, and maybe every run around the execution loop, it'll update all of those at once. But this is a fairly simple example, and I think it's a decent illustration of those sorts of principles. Any questions? Yeah?
It was just about, you were saying that it goes view, controller model, and then it goes back from the models straight to the view. Would it not, like you're going with the Mario example, say if the score was, say if the point of Mario was get your score to 1,000, say if your score was 1,000,
yeah.
then 1, the view would then have to go and do a check and say if it was over 1,000 then I've won. So shouldn't the model go back to the controller first and then to the view?
It could in some cases, but generally it's a kind of a tell don't ask sort of thing, where one layer tells the other what's happening rather than querying it. You could implement more or less the same thing in reverse, where the view would actually be actively querying the model for its changes rather than simply responding to a broadcast. But
It was the model should update the control. The model should update the control. So
the problem there is that the view might not be the only listener first. You could have other objects in the model layer that are listening to the broadcast.
yeah,
So it makes more sense to simply broadcast to all interested, regardless of what layer they're in. Because conceptually, if we had some other class here, in this case our model is one class, but in reality you'd have this kind of model umbrella class which would keep track of a lot of different things. But if there were several classes in the if there were several classes in the model that wanted to know about this score, I don't know, maybe there's some other object that's broadcasting the score to a dynamic to the internet or something like that. It wouldn't make a lot of sense to pass up to the controller first and then have the controller delegate it. Well, maybe in some cases it would, but in this case it's probably best that the model simply broadcasts and delegates. It handles that responsibility itself, and then allows whatever observers are there to respond in whichever way they please. And at least in that way, we can, maybe in some functions, if we did want to deliberately pass something directly to the view, it would make sense to go back through the controller to do it. But
I don't think the control. I think the controller task is only even listener or button handler, so it's only record what the user do. It doesn't do anything.
it doesn't do anything really of its own. It just handles.
Yeah, so it's never going to happen that model goes to controller, isn't it?
Very seldom. There could be cases. I think you're probably right in that there could be cases when it might be appropriate, but generally, updating another object on the state of the current object is usually done best through a broadcast of some sort, because at least then the model remains blind to who's listening to it.
I get the broadcast thing. It's
Yeah.
more the fact if there was some logic to be done before it got sent to the view.
Well, that would be done in the model before it's broadcast. Like in this case, we had the count increment